AB Calculus, Note Card 70, area between curves with respect to y. This is the 70th video lesson in the series inspired by Stacy McMullen, formerly of Dallas Independent School District, who developed this note card system. Now, in note card lesson 69, we did area between curves, and we found out if you had two curves here, say you have f of x and you had g of x. Okay, so we'll call this f of x, and this one here g of x, and this point here is a and b. And we have the area between curves, which is this area right here. And what we have in this instance is, instead of functions with respect to x, like you've probably done for most of the entirety of your math career, we're going to have functions with respect to y. And so we're going to have, let's say we have this one right here. This is going to be, we'll call this one f of x, or f of y. See, I'm in the habit of doing it already. And we'll call this function I'm drawing right here g of y. And we have the values here of c and d, and so we're going to be integrating. We're going to take the area that I've hashed in is integral between c and d of g of y minus f of y dy. So you may be a little bit uncomfortable with this right now. It's not as bad as it seems. But you have to sort of turn this around. And one thing you can do on some of these is you can, if you're more comfortable with x, you can change the variables to make it in terms of x type situation. 1, consider the curve y squared equals 4 plus x and chord AB joining points A, which is -4, 0, and B, which is 0, 2 on the curve. Find the area of the region R enclosed by the curve and chord AB. So we're going to make a little sketch here. So here's our sketch, and we have the curve y squared equals 4 plus x. So we have y squared equals 4 plus x, and if we subtract 4 from both sides of this equation, we have x equals y squared minus 4. And x equals y squared minus 4, it's going to be very similar to this one here, which is y equals x squared minus 4. Okay, here's y equals x squared minus 4, and I didn't put in all the other points, so here we go, right? But x equals y squared minus 4 is, we take this curve right here and we turn that curve sideways, and so that sideways curve is going to look like this. And I realize that it's a little bit off here. This will look something like this. So just to kind of clean this up a little bit, that looks pretty good. Doesn't take much cleaning up. You can pretty much see what this is here. Okay, we got I'll just leave this part of it up here. So a very rough sketch, but the y equals x squared minus 4 turns sideways, this is going to be the x equals y squared minus 4. So we have a rightward opening parabola. And we have this chord between points A and B. So point A is -4, 0, the x-intercept, and point B is point 0, 2. And we have a chord connecting these 2 points. And so the area that we're trying to find is between this function here. I'm going to call this function, just looking back here, remember we had if f of y is less than or equal to g of y. So we're going to call this one here f of y. And this line, we're going to call this g of y. So we're going to have g of y minus f of y. But we do have this one right here is our f of y. This x equals y squared minus 4. Now, let's take this line segment right here. We have y equals our y-intercept, which is 2, and we have a slope, a rise over run of 2 over 4. So y equals 1/2 x plus 2. And if we solve for x, because we want an equation in terms of x, we're going to get, subtracting 2, 1/2 x equals y minus 2. And continuing to work to the right, if we multiply both sides of the equation by 2, we get x is equal to 2y minus 4. And this is going to be our g of y. So now the rule, oh, by the way, we have these points right here. We're going to call them C, C, and this one here, D. Well, actually, it's the y value. So C in this case is equal to 0, and D is equal to 2. So we have this integral from C to D. That's our area, right? From C to D, we have g of y minus f of y dy. And working that out to what that really is, we have a is equal to, we have the integral from 0 to 2 of g of y, and g of y is our 2y minus 4 minus f of y, and f of y is y squared minus 4, and then we parenthesize this at the end with dy. And working to the right, we're going to remove the parentheses and get the integral from 0 to 2 of 2y minus 4 minus y squared, and minus -4 is plus 4 dy. And -4 and 4 cancel each other. So working below here, we have the integral from 0 to 2 of 2y minus y squared dy. And that's going to be equal to 2y squared over 2 minus y cubed over 3. And 2 over 2 cancel each other, and we go from 0 to 2. And now we are to our, using our fundamental theorem, big F of B minus big F of A, or conceptually what that is. So we're going to plug in 2, so we get 2 squared minus 2 cubed over 3. And then for minus f of a, we're going to have 0 squared, I'm going to parenthesize it, 0 squared over 2, actually it'd be 2 0 squared, right? Two times 0 squared, okay, over 2, and that cancels there, essentially 0 squared. And then we have minus 0 cubed over 3. So this part just zeroes out. So what we have left is 2 squared, which is 4, and minus 8 thirds. And 4 in terms of thirds is 12 thirds minus 8 thirds, which equals 4 thirds. And that's going to be our answer to this problem. So not too hard of a problem. It takes a little bit of mental gymnastics to change your equations and sort of think differently in terms of y instead of in terms of x. I hope this has been helpful to you. Good luck, and thanks for viewing.